Okay, for 7.3 homework help, I'm going to do 3 different problems. First 2 are going to be normal 3x3 systems, 3 equations, 3 variables. And then the last one I'll take a look at is a non-square system with 2 equations and 3 variables and what the answer would look like for that. So like we had mentioned in class, if you get a 3x3 system, it's your job to try to eliminate one of these variables, either the x's, the y's, or the z's. Our job is to try to get it down to a 2x2 system because we know how to solve those. So like we did in class, I'm going to number these equations. So as I do my work, it's easy to figure out what's going on. I'm going to multiply the top equation on number 1 by -1. So I'm going to say negative and then 1. I'll multiply the top equation by -1. I'm not going to do anything to the second equation, so I'm just going to say 2 with a circle around it. I'll go ahead and write down the second equation. And then when I add these together, I get the x's to cancel, which is what I was hoping to do for this particular one anyway. And then I'm going to number that as number 4. This is my new equation, or equation number 4. Now, picking 2 more equations, can't pick 1 and 2 again, but I can either pick 2 and 3 or 1 and 3. I'm going to do the same thing, try to eliminate x. So I'm going to pick equation number 1, and I'm going to multiply it by -3, which gives me -6x minus 3y minus 9z equals -3. Equation 3, I'm not going to do anything to it. So it's 6x plus 8y plus 18z is equal to 5. And I add these together, and the x's cancel again. This time I end up with 5y, looks like plus 9z equals 2. That'll be another new equation. I'm going to number that number 5. And now looking at equations 4 and 5, it's 2 variables, 2 equations. Now it's just like what we've been doing the last couple days. Try to get rid of either y or z. Looks like y is going to be easiest. So I'm going to say negative equation 4 is -5y minus 5z is equal to -2. Equation 5, I'm not going to do anything to it. It's 5y plus 9z is equal to 2. Get the y's to cancel like I was hoping to. And it looks like when I solve for z, I'm going to end up getting 0 if I divide by 4. So now I've gotten one of the variables. So now we're going to do what we call back substituting and go back to either equation 4 or equation 5 to figure out what y is going to equal. So I'll do that and bring that work over here. And I'm going to say, let's plug it into this one. 5y plus 9 times 0 is equal to 2. So, of course, that's just 0. If I divide by 5, it looks like y equals 2/5. And now I'll go back to my original equations, one of these. I'm going to pick the top one. You can pick whichever one you want. And I'm going to copy that down. It's 2x plus y, so plus 2/5, plus 3z, so 3 times 0, is equal to 1. Subtract the 2/5, which is now going to give me 3/5. I want to get a common denominator. Yes, I'm going to divide by 2, but it's probably easier to think of as multiplying by 1/2. And it looks like x is going to equal 3/10. And then like we normally do, we're going to write this as a point, 3-dimensional point. So we'll say it's 3/10, 2/5, 0. And so overall, your goal is to take a 3x3 and to break it down to a 2x2 like we're used to, because we know how to solve those. All right, so for the second example, you might remember me mentioning in class that I said try not to eliminate z. Try to either eliminate x or y. It's not that you have to. It's more consistent if we keep z in the equation. I'm going to show you here why we do that. So I noticed the first equation doesn't have a y term in it already. So I'm going to take the second and third one and try to get rid of y. It'll make me have to do less work. So the second equation, I'm going to multiply by -1 to get -3x plus y plus z is equal to -1. Third equation, I'm not going to do anything to it. And when I add these together, I get the y's to cancel, which is what I was looking for in this particular one. Whoops, I forgot to make that negative. So it looks like that should be 3x. I'm going to have a total of 6z and 15. And that'll be my new equation. And now I don't need to make another new equation because I have xz here, and equation number 1 also has xz. So I'm just going to use that equation. So now, like we always do, try to get rid of either x or z. Let's say I multiply the first equation now by negative 3, which is going to give me negative 3x. It's going to give me negative 6z, and it's going to give me negative 15. And so it looks like the x's cancels like I was hoping. It looks like everything does, and I get 0 equals 0. Like we mentioned in class, if you get 0 equals 5 or some other number, it's no solutions. If we get this implies that z is equal to z. And that's kind of the reason I wanted to keep z in the equation. It's not like I have to do that. I can use either of these variables. I could say x equals x. It's just more consistent, so we always use z equals z. And then you're going to back substitute, so you would want to go back to one of the new equations that you made. We only made one new equation, so we're going to go back to this one. Yes, we could go back to this one as well. And we're going to plug z in for z, if that makes sense. So equation 4 is 3x plus 6. If I thought z was 5, I would plug 5 in here. Well, we're saying z is z, so it doesn't actually change. And so the only real difference is when I solve for x now, I'm not going to get just a number. I'm going to get an expression. So I'm going to subtract 6z, and I'm going to divide by 3 like I normally would. Make sure you divide them both by 3. And so there's what x is equal to. And just like up here, once you knew what z was and once you knew what y was, you plugged it into one of the original equations to figure out what x is. Same idea. I know z and x, so now I'm going to plug it into one of these two to figure out what y is. So I'm going to pick equation 2, which is 3x, but we're saying x is negative 2z plus 5, minus y, minus z, which is still z, equals 1. Going to go ahead and simplify or distribute. So negative 6z plus 15 minus y minus z equals 1. If I get everything to the other side other than y, it looks like I have a total of negative 7z, so I'll be adding 7z to both sides. I have 15 here, so I'll subtract 15. And then, of course, multiply everything by negative 1. And now I have x, y, and z, and just like before, I'm going to write it as a three-dimensional point. I'll just say x is negative 2z plus 5, y is negative 7z plus 14, and z is z. And when I do this, you're going to notice the book switches z into a w or an a or some other variable. You don't have to do that. And like I said, if I had come over here and I had said x equals x, then here I would solve for z, and I'd have z equals something with x in it, and I would have y equals something with x in it, and then this would look a little bit different. This would be an x, and then this would be an equation with x and an equation with x, and that's technically okay. It's just easier if we all do the same thing, so I prefer that you keep z in the equation so that we always say z equals z. So that's kind of the reason in class I said, even though you probably aren't going to get z equals z most of the time, keep z in the equation in case you do. So then the last one for this section is what we call a non-square system, where I have more equations than I do variables. If that happens without doing anything, I automatically know I'm going to get a z equals z kind of answer. So knowing that, I need to get these equations down to either x and z or y and z, one of the two. I just need to have z in it. So now either try to get rid of x or try to get rid of y. So I'm going to multiply the first equation by 2. And that's going to give me 4x minus 6y plus 2z equals negative 4. Of course, I'm not going to do anything to the second equation. I want the x's to cancel for this one. So negative 4x plus 9y plus nothing equals 7. And good idea to leave the space there for it. Cancel the x's like I wanted. I'm going to get 3y plus 2z equals 3. There's my new, what I would normally call fourth equation, but I guess it's the third equation this time. And now since it's a non-square system, I already know this is true. So now I'm going to quote unquote plug z in for z and then solve for y. So I'm going to subtract the 2z to the other side. So I kind of need to understand that the answer is going to be a z equals z answer. Going to go ahead and divide by 3. It's going to give me fractions, but that's fine. So negative 2/3 z plus 1. There's what y equals. The only thing I'm missing is x. So go back to one of the original equations. You can pick the top one. You can pick this one. I might pick this one because there's no z there, but it's not going to make a difference. So since the y number is smaller here and I'm going to have to plug fractions in, Maybe I decide to pick the top one. Like I said, it doesn't make a difference. I have 2x minus 3 times y, which is negative 2/3 z plus 1, plus z, which is z, equals negative 2. And now distributing, again, careful with the double negatives like always. 3's would cancel. It looks like it's going to be positive 2z minus 3 plus z equals negative 2. Getting x by itself, you have a total of 3 z's that you need to move to the other side. So subtract 3z, add 3, and then the last thing you have to do is, of course, divide by 2. So you end up with negative 3/2 z plus 1/2. And now, like we always do, we'll write it as a three-dimensional point. We'll say my answer is negative 3/2 z plus 1/2. There's my x value. My y value is negative 2/3 z plus 1, and z equals z. And so there is my answer. If you have questions, feel free to email me if you need help with anything. Otherwise, best of luck.